After finding evidence of life on Proxima B, an exoplanet in our nearest star's habitable zone, NASA scientists are in complete panic. Advanced telescopes detected a properly calibrated narrowband signal that was too clear to be natural, causing a worldwide panic and irrational speculation. Experts are pushing us to reevaluate all of our knowledge about space, referring to it as a cosmic postcard from an unidentified source. Is this the first concrete indication that we are not alone in the cosmos? An extraterrestrial signal from Proxima Centauri was detected. Near our cosmic doorstep, astronomers have made an interesting finding thanks to recent advancements in the field. Scientists are ecstatic when astronomers discovered an enigmatic radio signal emanating from Proxima Centuri, the nearest star to our solar system. In contrast to the vast ecstatic emissions commonly emitted by stars, galaxies, and other natural phenomena, this signal is notable for appearing in an extraordinarily narrow band of frequencies. Because of the signal's exact composition, researchers think it might not be random noise from space, but rather a purposefully designed message. The identification of this week's broadcast has been made possible by sophisticated detection tools, such as sensitive radio telescopes with features like phased array multiplexing. The signal comes from Proxima Centauri's habitable zone, which is the area where circumstances could support liquid water on planets in orbit, according to researchers. Because it suggests that the signal might be connected to Proxima B, an exoplanet known to inhabit this life-supporting region, this minor information has important ramifications. Numerous natural explanations have been ruled out by early investigation, and the frequency's clarity and stability point to intelligent design. Scientists from all across the world are currently attempting to confirm the discovery through thorough testing and repeated observations. They are also investigating the possibility that previous technology constraints may have caused them to overlook additional comparable signals. In addition to providing a fresh perspective on the hunt for extraterrestrial life, the discovery of this narrow band transmission calls into question our present theories about cosmic communication. It serves as a celestial lighthouse, beckoning more research and cooperation. The hypothesis that there might be evidence of intelligent life in our cosmos just waiting to be found is strengthened by each new detail. And it's possible that this discovery will mark the beginning of a new age in interstellar communication and astronomical research, recognizing the ramifications of narrowband signals. The vast and disorganized noise that is frequently seen in space contrasts sharply with narrowband signals. The majority of natural sources, including pulsars, stars, and cosmic collisions, release signals that span a wide frequency range. A narrow-band transmission, on the other hand, is extremely uncommon and notable since it is concentrated in a small portion of the spectrum. This particular focus suggests that the signal may be a well-planned communication rather than just a random occurrence. Such a signal is sometimes compared by researchers to a single distinct note played on a musical instrument amidst a flurry of background noise. It is precisely this clarity that attracts scientific interest. The case for an artificial source is strengthened by the Proxima Centauri transmission's tightly specified frequency, which offers little opportunity for chance or natural explanation. This kind of signal is frequently linked to cutting-edge technology where accuracy is required for efficient information transmission beyond cosmic distances. Its existence raises the possibility that the sender purposefully selected a frequency range that reduces interference, guaranteeing the message's integrity over billions of miles. Additionally, the signal is easier to discern from naturally occurring background noise, which is typically diffuse and unpredictable due to its narrow bandwidth. In the wide and tumultuous sea of space, it acts as a beacon. According to a number of theories, if there is an extraterrestrial civilization, they may employ comparable techniques to make their presence known or to intentionally communicate with other sentient entities. Scientists are excited by this prospect because it turns the pursuit of extraterrestrial life from a theoretical quest into a real-world technical problem. High-resolution radio telescopes and sophisticated data processing algorithms are examples of improved technology that has made it feasible to detect these tiny communications that previous generations could have missed. Our ability to distinguish between artificial signals and natural phenomena increases with every new discovery. In addition to furthering radio astronomy, this development is paving the way for research on interstellar communication, which may reshape our position in the universe. These developments demonstrate the revolutionary power of science in revealing latent messages from the cosmos. Sophisticated methods for analyzing and detecting signals. In order to detect feeble signals from the remote regions of space, modern radio astronomy mostly depends on state-of-the-art technology. Phased array multiplexing is a crucial method that enables several radio dishes to function as a single, potent instrument. By increasing sensitivity and resolution, this technique makes it feasible to pick up faint signals that would otherwise be obscured by background noise. By integrating information from a network of telescopes positioned in various locations, scientists are able to identify a signal source with remarkably high accuracy. Along with advancements in hardware, sophisticated software algorithms have been created to swiftly process enormous volumes of data. These algorithms separate signals that exhibit odd patterns and filter out common interferences, distinguishing intentional manufactured communications from chance cosmic phenomena requires this digital processing. These initiatives are further strengthened by international collaboration among research institutions. Near real-time data sharing across observers worldwide guarantees that anomalous signals are confirmed by separate observations. This kind of cooperation reduces the chance that regional mistakes or equipment failures may affect the outcome. Radio astronomy has changed as a result of the combination of cutting-edge software and complex hardware, which allows researchers to investigate phenomena that were previously unattainable. Every improvement to detecting systems broadens our capacity to look for indications of sentient life, while also improving our understanding of the universe. The narrowband signal from Proxima Centauri was recently discovered, demonstrating the effectiveness of these technologies. This innovation has proved that with the correct tools, we can listen more intently to the universe and reveal signals that have stayed concealed for millennia. These methods are still being improved by ongoing research, which bodes well for future advancements in sensitivity. These advancements strengthen our investigation and broaden our comprehension of the enigmatic signals resonating throughout the universe, unlocking the cosmic message that was produced. The next big problem is deciphering the signal once it has been identified as odd. Researchers believe the broadcast from Proxima Centauri may be a purposeful message because of its ordered form. Scientists start by examining the signal's regular pulses and recurring patterns in order to decipher their significance. Specialized algorithms are used to look for geometric shapes, simple arithmetic progressions, or numeric sequences. These methods are taken from disciplines like linguistics and encryption. A universal language that any sentient being might comprehend could be represented by such patterns. One challenge is that the intended meaning can be predicated on ideas that are far outside the realm of human communication techniques. Rather than relying on words, the message may use basic mathematical constants or self-explanatory visual representations. However, scientists must also rule out the possibility that the pattern was produced by natural astrophysical processes or Earth-based technologies. Cross-checking data from several observatories and removing any interference from terrestrial signals are two ways to accomplish verification. To confirm that the observed signal indeed comes from the far-off star system, each piece of data must be reanalyzed. The question of whether this is merely a cosmic aberration or proof of intelligent design is still up for debate given the frequency's remarkable precision and apparent repetition. As researchers painstakingly go through layers of data and evaluate numerous theories, the decoding process is anticipated to take several years. Notwithstanding the difficulties, many people believe that figuring out the message will provide important new information about the nature of interplanetary communication. There's more to this endeavor than just interpreting a few symbols or numbers. It involves comprehending the motivations behind the message. A message from an extraterrestrial culture would probably reflect their scientific understanding, cultural values, or even a wish to make contact if they are in fact attempting to communicate. Every new discovery puts humanity one step closer to maybe making first contact as scientists hone their methods and disseminate their discoveries throughout the world. The process of deciphering this well-constructed cosmic message is a prime example of the spirit of curiosity that propels scientific research. Cosmic secrets could eventually be revealed with perseverance. Investigating the possibilities of Proxima Bs and the Proxima Bs and the Proxima Centauri system. Because of its closeness to Earth and the existence of at least one known exoplanet, the Proxima Centauri system has long captivated people. The habitable zone is where the small red dwarf star Proxima Centauri and its closest companion Proxima B orbit. This zone is the region surrounding a star where temperatures may be suitable for the existence of liquid water, which is necessary for life. Even though Proxima B is neatly locked, careful examinations over the years have shown that it may contain an atmosphere and climatic conditions that could support life. Interest in this system's potential has increased after a narrowband signal was recently detected emanating from it. Researchers are now speculating on whether the signal could be directly associated with Proxima B or even with a man-made object orbiting the star. Such an object might be a craft or satellite, demonstrating a degree of technological development that is far beyond anything we have ever seen. Telescope data has helped determine the planet's habitability by shedding light on the star's magnetic activity, flares, and general stability. Researchers can assess important elements including radiation levels, climate dynamics, and potential chemical compositions in the atmospheres of neighboring planets by examining the Proxima Centuri system. Understanding the potential for extraterrestrial life requires an integrative approach. Furthermore, the fascinating prospect that we are seeing evidence of intelligent life is increased when a narrowband signal is combined with Proxima B's known properties. Our beliefs regarding Earth's uniqueness and the existence of life in the universe would be called into question by such a revelation. As part of this effort, astronomers are preparing future missions to conduct more in-depth explorations of systems such as Proxima Centauri, in addition to collecting observational data. Every new piece of information advances our knowledge of planetary systems that are near to us by adding to a bigger puzzle. The significance of near-Earth investigations and the larger framework of interstellar travel and the hunt for extraterrestrial intelligence is underscored by this ongoing study. Research keeps going, stoking curiosity and optimism. Implications of the signal for society and science. Both science and society will be significantly impacted by the narrow-band signal detected from Proxima Centuri. Our perspective of life and the cosmos would be altered if it turned out to be artificial, as it would provide the first tangible proof that we are not alone. This discovery compels scientists to reconsider their long-held beliefs regarding cosmic communication. It offers a unique chance to investigate a possible message from space that could have ramifications for everything from biology to physics. The assumptions that have governed astronomy for decades must now be challenged as researchers incorporate this discovery into pre-existing frameworks. Practically speaking, the detection propels the creation of increasingly sophisticated technology and signal processing techniques. Projects that concentrate on the hunt for alien communications may receive more funding and resources, encouraging creativity and cross-border cooperation. Beyond the scientific details, there would be extensive philosophical and cultural discussions if alien intelligence were confirmed. A meeting with a different civilization would have far-reaching effects on everything from politics and ethics to how we all view ourselves. A new generation of scientists and explorers could be inspired by educational institutions incorporating this discovery into their curricula. Public interest in space exploration would probably change as a result of media coverage of such a significant event, which would also motivate governments to increase funding for scientific projects. The conversations would also cover moral issues with contact protocols, stressing prudence while welcoming inquiry. The requirement for thorough verification and the creation of procedures to deal with a verified alien message are two major obstacles that still need to be overcome. Notwithstanding these obstacles, the finding has already changed public perception and brought disparate groups together in a common pursuit of knowledge. The signal is a powerful reminder of the vastness and mystery of the cosmos we live in. It emphasizes how much we still don't know and how each new discovery changes how we perceive the universe. The narrowband signal is not merely a scientific oddity in this context. It is a significant cultural event that has the power to revolutionize our society and create countless opportunities for development, cooperation, and exploration. This life-changing experience motivates us all to seek knowledge and band together in our endeavor to discover the unknown. Yes, the enigma of the early universe. Our conventional theories about the early universe have been challenged by recent astronomical findings. Galaxies developed far earlier and more quickly than previously thought, according to telescopes using modern technology. Unexpectedly high degrees of complexity and order are seen in some galaxies that were discovered just a few 100 million years after the Big Bang. Conventional models that envisaged a gradual creation spanning billions of years are challenged by these data. The discovery of enormous black holes merging more quickly is equally perplexing. Located at the core of newborn galaxies, these black holes seem to be expanding and combining at speeds that are inconsistent with previous theoretical projections. Their quick development implies that the early universe's environment were particularly conducive to these kinds of activities. Dynamic gravitational interactions and thick gas concentrations are two examples of factors that may have greatly accelerated star formation and black hole expansion beyond what our models predicted. Light from these historic buildings is captured by observations made with cutting-edge equipment, enabling us to practically travel back in time. The photographs and information gathered provide insight into a time when the universe was very young and its constituent parts were constantly undergoing fast evolution. These findings compel researchers to reconsider the basic principles underlying cosmic evolution. To account for these unexpected results, updated models and new computer simulations are being created. Researchers wonder how the early universe could have supported such effective mechanisms of creation as they revise their theories. Studying these fast-moving events is essential because it changes our knowledge of black hole dynamics and galaxy formation while also providing insight into the universe's general timescale. We are getting closer to finding answers to important issues regarding the universe's beginnings with every advancement in this field. The unsolved early mysteries of black hole mergers and galactic evolution continue to challenge the state of science and call for more advancements in astrophysics. In addition to appending our preconceived notions, these revolutionary discoveries greatly motivate astronomers to improve their models and look for more comprehensive explanations for the swift processes that molded the early universe. Comprehension, the visible, the invisible, and the boundless cosmos. Only what we can see limits our knowledge of the cosmos. The distance light has traveled since the Big Bang establishes a limit that is invisible to us and defines the observable cosmos. However, sophisticated measurement methods and sophisticated telescopes show that the universe is much larger than this apparent sphere. Only a small percentage of the universe is visible to us. The rest is made up of enormous, invisible areas that could be the source of numerous mysteries. This boundary where space expansion prevents light from far-off objects from reaching us is known as a cosmic horizon. Furthermore, because of the universe's constant expansion, objects are moving away from us at times faster than the speed of light. This implies that a large number of galaxies and cosmic structures will always be concealed from view. Some ideas cast doubt on the idea of a clearly defined beginning or finish by speculating that the universe may potentially be endless in size and age. Scientists search for indirect proof of the invisible because of the interaction between what can be seen and what is hidden. Properties of the broader unobservable cosmos can be inferred from measurements of the cosmic microwave background radiation and the distribution of galaxies. Researchers create models that attempt to explain the structure and evolution of the entire universe by examining these hints. Significant queries concerning the nature of reality and our particular position within it are brought up by the notion of an infinite cosmos. Infinite variations of matter, energy, and even life are possible if space is infinitely long. This idea challenges accepted ideas in philosophy and science and broadens our imagination. Every new discovery adds a tiny piece to the enormous puzzle of life, and technological advancements keep pushing the limits of what we can perceive. One of the most fascinating and profound problems facing contemporary astrophysics is the pursuit of knowledge about the observable, the hidden, and the infinite universe. Our knowledge is constantly expanded by this never-ending quest, which also piques our interest in the endless secrets that are hidden from view. The Space Telescope of James Webb. The James Webb Space Telescope is one of astronomy's most innovative instruments. The JWST, which was launched following years of meticulous preparation and creativity, has revolutionized the way we perceive the universe. This telescope can see through clouds of cosmic dust and gather light from the first galaxies. Since it is specifically made to observe in the infrared spectrum, its primary mirror, which has a diameter of about 7 meters and is made up of 18 gold-coated segments, offers remarkable sensitivity and clarity. The telescope can gather weak signals from objects billions of light years away because of this architecture. To ensure peak performance in the infrared range, JWST also has a sizable sun shield that keeps its sensors incredibly cool. There were several redesigns, financial limitations, and technological difficulties along the way to its successful introduction. To make sure the telescope would function properly in the harsh environment of space, engineers put each component through rigorous testing. The JWST's scientific mission began when it was installed at the second Lagrange point, which is around 1.5 million kilometers from Earth. The photographs it returned exceeded all expectations. These pictures have provided previously unattainable insights into the fine intricacies of far-off galaxies, star-forming regions, and planetary systems. Scientists have already begun to reevaluate long-held beliefs regarding the early cosmos and the creation of cosmic structures as a result of the telescope's ability to see far into time and space. The James Webb Space Telescope would not have been possible without the cooperation of multinational space agencies. Its accomplishments highlight how crucial international collaborations are to expanding our knowledge of the cosmos. Every new discovery advances our understanding of cosmic development, generating groundbreaking theories and motivating further research. The JWST's findings include more than just stunning pictures. They reflect important scientific advancements that are changing how we perceive the universe and our role in it. As we work to discover the mysteries of our cosmic origins, future directions in space exploration, and the search for extraterrestrial signals, the James Webb Space Telescope continues to push the boundaries of astronomy with its unmatched capabilities, providing previously unheard-of views of the distant universe and inspiring the imagination of both scientists and the general public. Looking ahead, a daring new era in space exploration is being ushered in by recent discoveries and technical advancements. In order to record even more elusive and subtle transmissions from the universe, researchers are currently concentrating on improving detection techniques. To make sure that no possible signal is missed, future observatories will integrate real-time worldwide networks with increased sensitivity. Concurrently, there is a growing push to decrypt any message from space. Experts in computer science, astronomy, and cryptography are part of interdisciplinary teams that are creating cutting-edge algorithms to decipher intricate patterns and derive valuable data. As scientists and space organizations cooperate to gather resources, exchange data, and plan observations, international cooperation is essential. By working together, we can not only better identify alien signals, but also improve our ability to validate and decipher them. New mission plans seek to send probes to exoplanets that may be habitable, such Proxima B, which are close by. These missions will investigate surface conditions, atmospheric composition, and possible biosignatures in an effort to gather concrete proof of habitability. The distinction between science fiction and scientific truth is becoming more and more hazy as technology develops. Every new discovery we make during our explorations piques our interest and deepens our comprehension of the cosmos. The possibility of discovering sentient life outside of Earth is both exciting and intimidating, since it may completely alter our position in the universe. Even though there are still obstacles to overcome, the future is full of opportunities. Furthermore, each new finding advances our understanding of some of the most important issues facing humanity. Unending wonder and the unrelenting desire of knowledge are the driving forces behind the adventure to comprehend our cosmic environment, which has no end in sight. Breakthrough initiatives, creative space missions, and the unwavering efforts of scientists everywhere will expand our understanding of the cosmos in the years to come, providing fresh perspectives on the cosmos and shedding light on the way to a future replete with exploration and interstellar communication. These projects will transform our knowledge and close the gap between science and the mysteries of the cosmos. Thanks for watching another episode. Please like and subscribe for similar content.